I'm here. A little bit late, but I guess that's what's new. Yeah. Anyways, this is day 96. It's on the thing. Did I put the stream title correctly? Yes. Okay. This is day 96. Studying compilers every day until I land a compiler role. I'm really tired. I have some game dev homework to do, and today's been kind of a rough day. So, I think I'm gonna try and keep today's stream a little bit short, but hopefully it ends up, on average, not terrible. Yeah. So last time we wrapped up debugging stuff for tree merging, and by debugging stuff for tree merging, I specifically mean debugging our middle end passes, so that tree merging wouldn't vomit out various errors. So yeah, that's where we're at right now. Luckily, that's all resolved. I think that's all correct. I haven't checked the logic of tree merging yet, so I need to do that at some other point. But until that point, I think I want to at least get tree tiling somewhat started. I've explained what tree tiling is in the past, but basically for our instruction selection, I guess, stage of the compiler, with a lack of a better term, we do three things. The first thing we do is we take our IR, or intermediate representation, or I guess like memory representation of our program, and we turn it into a bunch of different, trees. So each instruction gets one tree, and that's kind of like the, I guess, most sparse possible representation of our program. From there, the next step is tree merging. So we take those trees when it's possible to, I guess, merge temporary variables. We do so, and we make larger trees out of them. And then third and final, so that's where we're at right now. The third and final part of this is tree tiling, where we basically take each tree that we've generated and we cover it with tiles that represent sequences of instructions. And what that lets us do is we can generate a better, I guess, set of assembly instructions that represents our program, rather than just doing like a one-to-one macro expansion, which might have some correctness issues. I guess not necessarily correctness issues, but like it might not be as close to optimal. So this should be a little bit better of a solution than that. And that's not to say that we won't do like micro optimizations at the borders. We'll still do a little bit of that, but that will come, I guess, later on in the process. So yeah, I guess we can get started with this. I've made a new branch here. Can I just push this? Yeah. Okay. Cool. So that branch is set up now. Yeah, let's go to lir tree. So we have this like tree tiling stuff. This has a visitor right now. It's kind of a visitor that doesn't really do anything, but I need to put something in here, and I don't really know what yet. I know I should make like a tile class, but I don't really know how to define this very well. Yeah, there's not really a clean way to go about this, I think. So yeah, I'm not really sure what to do here. I guess I should probably generate some tilings at least. Just based off of what we have, I think that would at least be a good start. We could probably start with like a minimal tile set, I guess. Just something that can like cover the entire tree, hopefully. So if we look at the nodes we have, we can kind of just like make very small tiles, and then we can expand our set of tiles to, I guess, work with more complex assembly instructions. So okay, so I guess register and immediate won't really get us a lot of immediate value. See what I did there? But I think we can generate them with pretty much every other tile that we have. So we have the op node tile that I guess we'll get a whole lot of different tiles. We need to figure that one out. We have the alloc node, which I guess I'm not really sure how to handle this. I think we should probably do something that hoists all of the allocs. At least to like one point in the program, so we don't have to worry about like more mess with like, I guess, dynamic allocation. Yeah, I would like to do that ideally. We have load, we have store, those are pretty standard. And then like, I think that's about it actually. So we kind of just need like, we need load, store, we need register, and we need, I guess, op node for now. I guess register node, if it has one child, we can turn that into like a move assignment, but there's not really much else we can do with that, I think. Yeah. Yeah, this is a little bit tough. I need to think about what the best way to do this is. So I guess a tree we'd have to like traverse in backwards order almost, I think. We'd have to like traverse it bottom up, which is like fine. We just need to like, I guess, do that. Yeah, okay. So I guess we could get started with that. I need to figure out how to do this alloc hoisting stuff because we definitely make a little bit of a mess there. I think I'll need to clean that up in the front end, but that'll come at a future time. Yeah, actually, how do I do that? How should I hoist the allocs? Actually, let me look at this more closely. I think we could look at some like example IR that we've generated. Let's look at like expected. Let's look at like memtoreg MIR, or like the Actually, yeah, this is good. So like in this instance, I think it's already hoisted. We might just want to make like a dedicated entry block that just has all of the allocs in it. Yeah. So this is an example of what would cause a problem. I could also honestly just like make the code gen for like binary ops a little bit cleaner as well, but I don't know. Yeah, okay. Yeah, I'm gonna need to figure out a way to hoist all of these, I think. That would be nice. Maybe that goes in like, I guess what stage would that be at? I guess I would put that in like HIR maybe? Yeah, I would put this in the HIR stage, and then ideally what we would do is we would like move all of these int declarations upwards. I could probably also just update the front end to like not generate as many intermediate variables because this makes way more of a mess than I think we need to. Actually, that might be something I do first here. I think that will clean up the output a lot. Yeah, so the stream title might be a little bit misleading, but yeah, let's do that real quick actually. AST to HR. This is the pile. So if we look at this again, we visit all these expressions, and the way we do this is like kind of recursive. So I think that is where the mess is coming from. The while is fine. Let's go to Bigger. I think I remember you. Yeah, I don't remember which stream you showed up, but your name is familiar. Hopefully you've been doing all right in the time that I guess we haven't been around. Okay, so yeah, so let's look up accept here. While is fine. Okay, this is where all this starts. Wasn't the UAE? Fair enough. Yeah, hopefully you had a good time there. Okay, so call, this makes sense. Yeah, so we gen the args, that's fair. Those do need to be independent, I think. Yeah, those do need to be unique, unfortunately. I think this is fine. Grandpa died, my condolences. How are the compilers doing? It's been alright. I've made a decent amount of progress. I'm on the back end now, but I'm looking at the front end for a second just to hopefully clean up a little bit of my code. I would like to avoid this make temp business here. There's a lot of like make temp stuff, and that makes a little bit of a mess. Term is I think this is inevitable. Maybe I could rename this to like var. Yeah, this should be like var. I guess we could shorten it like that. What is the terminal expr again? I forget what I was doing. Oh, this is just... Okay. Sure. I don't think I need to like explicitly cogen this, right? Or maybe I do. That might be necessary. Yeah, that should make a variable. Call, I think we kind of need to make a temp for. Unary op we definitely don't need to make a temporary for. Okay, so we have the value. What type is this? This is an identifier. What's good, Skittles, and welcome, Jordan. I don't think I've seen you around. Microsoft driving you crazy with this Office 365 stuff. Yeah, it really sucks that everything like the world runs on Word for some reason. Microsoft products and Word, and now everything is going to garbage. What's good, Relics? Good to see you. Okay. In case y'all didn't hear that when I mentioned earlier, I'm actually taking like a small pause from all the backend stuff to clean up my front end. We generate a lot of temporary variables. That makes a little bit of a mess in the way I want to, I guess, generate trees. So I'm planning to at least clean this up a little bit and reduce the number of temporary variables we make. In the grand scheme, this won't matter unless we're like running without optimizations. But it's still just nice to have, if at all possible. What is happening here? Make temp. Okay, so we take this temporary value. What is last expr? I think there's a visitor defined in here, right? Or no, it's an AST HIR. Last expr. Okay, so that's an atom identifier putter. So I want to do this twice, actually. Yeah, so let's make this like read value, or value read, and then we can do like value write or something like this. We can get rid of that, or actually this is a unique putter to atom identifier, so we could kind of just keep this. We can do this var declare, maybe we can just like do that actually. Let's give this a try. Hopefully this doesn't make a mess. Oh, we shouldn't declare then, actually. This should take... var assign? Wait, what am I doing here? Okay, wait, let's... okay, let's get rid of this. So this should be... yeah, let's just make this... let's just do what I was trying to do before. So let's copy this, or let's rename this first. This is read, and then this should be write. Okay, so we can make 2 copies of it. Yeah, so we don't want to really declare, we don't want to do this declare anymore. This assign is a little bit silly. Yeah, so we can get rid of this declare. Let's just rename this actually. Our assign. Yes, let's get rid of that as well. What is last expir again? I'm setting this. This I don't think we need to change actually. Right? I guess just to be safe we should var assign get. Yeah, that should just be value once again. Yeah, okay. Had a stressful week ahead of me, have a bit of the Sunday scaries. Yeah, it is kind of like that sometimes. You'll get through it though. I'm sure you will. We'll do it like this so that it's in line, I guess. Okay, so we can get the value, and then this I think should just modify it in place. Hopefully this works. If this works, then the next thing to do is to update binary op, because this makes a lot of temporaries. I would like to reduce that number as much as possible. It will inevitably make 2 temporaries, I think, but we can cut that number down from 3 down to 2 at least. This rebuilds a lot because a lot of stuff depends on this file. So this should fail tests, right? Okay, yeah. This fails a lot of stuff. Interesting. Which ones does it fail? It just fails a bunch of the HR tests, interestingly enough. I'm a front-end dev. How to even get started with this? So there's like 2 books that I've been recommending to people. The first one is Crafting Interpreters. It's a web book. It's completely free. If you're completely new to like programming languages work, I think that's a very good place to start. After that, if you want to like work on a compiler proper, I think Writing a C Compiler by Nora Sandler is probably the next resource that I would point you towards. Let's run the test generator real quick. Okay. Let's check out like the call chain. Yeah, of course. That should probably get you a decent bit of distance into whatever you're working on. Getting into iOS dev, but kind of scared if I put it on the work I won't be able to get a job. Nah, I think you got it. The job market's definitely tough in general, but the job market is always good for people that are cracked. So, I think in that sense you'll be fine. I'm sure you'll make it. Where's the part here where we apply a sum up? I guess this file doesn't really have anything that we can look at for saving lines. Let's look at a different test. Let's go to op.hr maybe? This might have something interesting. It's a bit daunting, yeah, it definitely is, but if you put in the hours, if you keep going at it, I'm sure you'll make it. What are your dream companies? I think one of the large quant firms is probably the most obvious place I want to end up. So like HRT is probably a big one. And then just like the other usual quant pile. Aside from that, I think big tech would be pretty cool. I think that's like the big pile. Yeah, I mean, it's not really specific. I don't really care as much about where I end up as much as what I'm doing. So I think that is what's interesting for me. Waiting for you, thank you. Most people who are law firm persons get jobs? Yeah. I mean, it definitely happens, and like, not to say that like it's not gonna happen, but like there's definitely more uncertainty the less skilled someone is, I think. Are called by, okay, this one we can skip, I think. Yeah, so we don't care about var declare anymore. So this should be var assign. And then we can get rid of that, I think. It's almost like they get cherry picked. They referring to low effort or? Yeah, that statement's a little ambiguous without, I guess, context. Yeah, interesting. I guess, yeah, I mean, I don't have like a complete idea of what happens behind the scenes. It's all about like how well you can market yourself at the end of the day, I think. Okay, so we do that. And then last expr should be var assign, I think. Yeah, we should do that. Or actually, no, we should take the value from the left, I think. Yeah, this would make sense. Yeah, I like this. What else can we do here? This should definitely be value. Get value, actually. Okay. This looks about right, I hope. Yeah, hopefully this is all fine. We'll find out very quickly if it's not fine. Feels like compiler dev and OS dev are a dying breed. Yeah, I kind of get that vibe as well. It's all just like, everything's very web devy and very AI right now, because that's like, I guess that's where the most marketable impact lives, at least, because like I think a lot of people go into CS just because of like what they hear about from like business people, or at least like what they're told about it gets filtered through what business deems as valuable. But there's always going to be like a lot of work behind the scenes that I think people don't really recognize, and there's a whole layer of depth that's interesting there. Can you create a compiler from any language? What do you mean by from? Like, if you mean like writing the compiler in a language, I guess the answer to both Both instances, yes. You can write a compiler in any language technically, as long as like you can like read from a file and like you don't even need to read or write from a file. You just need to like be able to accept input, and then like if it's like Turing complete, you should be able to create it. And then like you can definitely, if you mean like as an input language to the compiler, I think that's also possible. Some languages are easier than others because I guess the easier it is to write a language, the more work behind the scenes needs to be done. Like, if you look at what a Python number actually is, there's so much behind the scenes. Yeah, there's so much stuff that happens that it makes a complete mess out of, I guess, any compiler implementation for it. Oh look, okay, this is a little bit less verbose. That's very good. I'm gonna compile myself a goon sandwich. Yeah, take care, Vigro. Good to see you around again. What's good for a night gamer? I imagine you're surviving a little bit better today. Okay, what is happening here? This arbitrary distinction between call and I guess call is fine. I don't know, this makes like a little bit of a mess though. I don't really like how I'm distinguishing these make temp things. These are all just turning into var, I guess. I guess we could just, can we even just like simplify this even more and just make it v? Let's try this up. Just realized I fell asleep for the first 22 minutes of the stream. Yeah, I mean, it happens. I don't blame ya. Everyone's tired. Everyone's overworked nowadays. All right, let's see what's happened here. Okay, on average the verbosity should go down. I don't think this changes correctness at all. We just compact things down a little bit. I think this also represents like the operand order a little bit better. What the hell is happening here? Where is this res value coming from? Oh, that's from the return, huh? Anyways, that wall of garbage is still a wall of garbage. That's still very messy. I don't like that. I'm gonna cram an extra 15 minutes of study and go to sleep. That's fair, yeah. Good luck, man. Yeah, hopefully it all goes well. Let me know how it goes. How's C#? It's all right. It feels very fluid to write, I guess. At least coming from a C background, it kind of just writes itself. I'm only really writing it for my game dev class, but I think the amount that I've like written for it is like it's felt good, at least I will say. I think using writer for it, because I can't figure out how to get WSL NeoVim to work properly with Unity. I've been using writer for it because that's what we need to use to debug, apparently. Or as in, like, we literally are not allowed to go to office hours if we're not using writer for some reason. But yeah, it's felt very fluid. I found it kind of just like workflow wise, it's not been as bad as I expected. But I'm also kind of half vibe coding it, so like it kind of is what it is. Yeah, so much output here. This doesn't really get compacted down. Gave up on WSL NeoVims, too hard to configure. Yeah, fair enough, yeah. I guess most of my development stuff is in WSL, so it's been like all right for me. But unfortunately, I can't really stick Unity in WSL, so that's the problem I'm running into. SSA in the IR, yes. My middle end IR is SSA. Just like, I guess just to like kind of prove it. Here's my memtoreg pass. I'm gonna go through it really briskly because I kind of have. I guess it's all open source, so you can take a look at it. It's all on my GitHub. Yeah, this is like the fee insertion stuff. This is the variable renaming. If you're familiar with like the standard SSA construction algorithm, it's not much different. Yeah, and then like we do a little bit of like cleanup work. What's good, Kane and Ted? Good to see y'all. Man, chat is popping today. That makes me rather happy. Yeah, maybe I should do something with this terminal expert and just like handle a number differently. I guess maybe not. This is fine. Let me check my fantasy league real quick. One of my friends is molding. I need to see what's happening there. Importing my compiler to Windows? That does not sound fun. Yeah, good luck with that one. Ah, I see. Jalen Hurts is not having a good time. This brings me joy. Okay. Okay. I think that's most of the cleanup work I needed to do here. Yeah, okay. So let's make test. What's good, Niraj? Good to see you. Oh, something is breaking. What the hell is breaking now? Josh Allen? Yeah, I also have him. He might be the best running back in the NFL, I fear. Why is this failing though? That's really strange. That should not be failing. I guess let's look at the Git status. Not a lot should change here. I guess a lot of the MIR changes for some reason. I guess why is that different? Yeah, let's look at the regression output for some of this. Yeah, he is a quarterback, but like he might be a little bit greedy. What can I say? I have him started as well, so I am raking in the cash. And by cash I mean the points. I am not raking in cash at all. So which test is breaking? Test LR for call chain? Really? Why is this one failing? That doesn't make sense to me. Main ID used IntelliJ. Oh yeah, just like it's like the usual JetBrains pile and then like Visual Studio. That's fair. I've always just been like, I've never really been a big IDE person. I feel like they're just really heavyweight for what I want to do, at least. Can people put public issues for security vulnerabilities? Yeah, I mean, that definitely is not ideal. I imagine there's like some solid rationale for it. So why is this failing now? Youngsters ID? Yes, that is how I think about it, at least. So why are the tests failing? The fuck? Yeah, let's run this real quick on Test regression input tet call chain. The hell? Oh, dash O0. Interesting. I'm not sure why this is happening. What the hell? In merge trees 39. What the hell? Size is greater than 1. Wait, what? So that should not be capable of failing. This literally is not supposed to be able to fail. What the fuck? Yeah, that one doesn't really make sense to me. Yeah, that doesn't make sense. Will I do anything special on day 100? Maybe I will, maybe I'm not. I'm not really sure yet. I need to think about it a little more. What is happening here? I'm really confused why some of this is breaking. Day 100 coding with viewers? That could be funny. I'm not really sure how I'd set it up, and I don't have the time frame to really think about that, unfortunately. Why is this breaking? This doesn't make any sense. So we're calling back. But it shouldn't be empty. It literally should not be empty. That doesn't make sense. Okay, let's just empty it here. If it's just not empty. That might be safer. Wait. Wait, what? What am I doing here? Oh. So this is a check. So that one should be, that one needs to be that. But this one can just be not empty, I think. And so if it's not empty and back is not the same, then we skip. If it's larger than 1, and that, then we skip. This should not fail. This literally should not be failing. Why is this failing? I don't understand what's happening here. What the fuck? I'm so confused. This shouldn't fail. Merge trees 43. The size, so size is greater than 1. So back shouldn't be causing problems. References incorrectly deduced? Yeah, maybe actually. What is... Yeah, so back should exist though. Back should exist if size is greater than 1. This line is the one that's failing. I could just revert the changes and not care, but it feels irresponsible to do that at least. I'm so confused. I don't see how this could happen, at least. So we're comparing the back element to the second to back element. If you direct it and compare it to an iterator, yeah, it should be valid. Oh wait, back is back. No, back is a ref. Yeah, back is a ref, and then the deref of the iterator should be fine. That's odd. Maybe my delete logic is wrong then somewhere. I guess we could just like run it through a debugger. Yeah, let's give this a try. Let's do that. Debug bin panic. Okay, is this the first? Okay, it's definitely not the first time that we look at it. Okay, this is fine, right? Where's... Okay, I should probably break at the actual place that we care about. Yeah, okay, let's just send it. which one do we care about? We care about here, roughly. Just rerun it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 11 is the number. So let's just try this again. Actually, wait, did I just keep hitting F1 instead? Where is T2 uses? Wait, what? Wait, huh? Size greater than 1. That's strange. Yeah, so that's breaking. Well, how are we getting past that? That should short circuit, right? It's a double end, so that should short circuit. Why isn't it short circuiting? So 7. I swear I had a bind somewhere. 1 second. DAP. I swear I had a bind for like... Oh, I don't have a bind for view variable at cursor. Why isn't the short circuiting? Wait, is this some operator precedence thing that I'm messing up? No, it shouldn't be. This equals equals comes before the double end. This is false. We shouldn't be evaluating the thing inside at all. I don't know, let's throw parentheses around that. The hell? Like, this shouldn't be happening. Okay, let's... Not guaranteed by C++? Really? It should be. Is there any role for a compiler? Yes, there are plenty out there. Not as many as like WebDev, but there are definitely enough for me to find something. This week might be cooked for me in fantasy, by the way. F in the chat. Yeah, that's not ideal. Unless Trey Tucker pops off on Monday. For custom overloads not guaranteed? Yeah, that's what it looked like. Let's write it differently. This doesn't make sense. Size should be 0 here. Okay, let's just do this and then we can view size. Yeah, let's do that. Let's keep this as 1. Set debug here. Do you think Python with DSA necessary requirements? Oh, I see what you're saying. I think the knowledge is still very important. Like, you'll struggle to write good Python code if you don't know, like, if you don't understand dictionaries very well. And like, even if Python is not necessarily like the most performant language, you're still expected to at least know how to, like, I guess, do things. DSA in general is like, I think it's something that like everyone needs to know regardless of what language they're working with. Because like dictionaries, hash tables are everywhere. Dynamic arrays you will be using everywhere. As a matter of fact, you can't not, you're kind of required to use them in Python. So that's important. And like if you have a problem that requires a heap, for instance, and like you don't know what a heap is, then like you're in big trouble. Yeah, I think it's just generally very important. Let's launch last. Oh. Size is 1. Oh. That's not what size is supposed to be. Why is size that number? Where does that number come from? What the fuck? I think we found the issue here. Why is that the number? Where does this come from? Something seems a little bit off here. So now if I run through this, yeah, so that's not supposed to happen. Why does that happen? Huh. I think we found the culprit. Didn't it used to pass as a new test? It used to pass. I changed the way I structured this though. I changed the code gen a little bit from in the front end, so it makes less intermediate variables. Why is that number so large? That shouldn't be happening. So it'd be in here maybe? So none of these are a 7, or none of these are like a 4, 5, 6 digit number. Yeah, we should check what git name is actually. That might be smart. Honestly, if the uses is empty, we could probably just skip it. That would be the lazy way to solve this. Yeah. We should probably do that anyway. But this doesn't sit right with me. That's really strange. Let's, okay, send it again. Yeah, that breakpoint's still fine. Let's wait for this to build. Yeah, that number is strange. I've not seen that before, I would say. Oh, that's not the right button. That's not, wait, what? Uses stores to list directly. Oh, wait, that could be it, yeah. Huh, but... yeah. Honestly, I think if I just filter out the empty lists, that would solve every problem, right? Yeah, I should just filter out the empty lists, I think. Yeah, find is definitely a good call. I imagine what's happening at this point is everything with it has been merged. Is that the only place that it's used even? It looks like it's the only place it's used, at least there. Yeah, I think bracket operator is trolling me here. Yeah, let's do this. Or is it find? What type is this again? This is a unordered map. C++ reference. Find. Okay, so end. Okay, yeah. So we should do find. What is this? This returns an iterator, so I don't think this needs to be a ref. Yeah, okay, let's clean this up real quick. Let's do that. Use, okay, let's do. Oh wait, this is not Rust. I need to put parentheses around things. Yeah, we should just skip if it's empty. So now we know it's not empty. So definitely exists. I think now we can deref that, right? Oh. Right? Oh, that's annoying. Okay. Let's just... we want T2 uses iter second. This is not the prettiest way to do this. Yeah, it is what it is. Is this a ref by default? No, I think I need to make that a ref. Okay, yeah. That's fine, so we can do that. I think this is fine. This will just make a mess, but it is what it is. Hopefully this doesn't crash now. We should be skipping the empty ones anyway, so I think this is ideally fine. Well, it's not fine. Okay. Interesting. That's not ideal. Let's set a breakpoint here. That. I'm not really sure what's going wrong. I don't know about you guys, but wait, what? Wait, what? Wait, I'm so confused now. Let's throw it in Valgrind again. Is it the same place? 43. It's here? Okay. Let's throw this here. Let's just get T2 uses, iter second, empty. Let's just do that. Okay, so that should be good. Oh, okay, that works. Okay, empty chuck. Okay, cool, great, yippee, wonderful, excellent. Okay. minor inconvenience, minor crash out. I imagine that means something else funky is happening behind the scenes, but honestly, at this point, if any of my code remotely works, it works, so I can't really complain. Yeah, so we're just gonna cover this up. Just gonna paper over everything. Okay. It skips all the correct tests. It passes all the right tests. I definitely could have just skipped this issue altogether, but yeah. Yeah, okay, that seems correct. I hope this is correct. Or maybe we could restructure this actually. Or empty. And we continue. Yeah, actually, we could just do this, I think. Yeah, and then we can skip this like extra, this gross line. Yeah. Let's see if this works. Holy shit bar. Gotta... Okay. Let's make test. Edge cases where guardian is listed 0 or the key doesn't exist. You can do it more concisely? Probably, yeah. We could definitely check contains first, I think. But then we'd be like searching twice, so I think this is like fine. I don't think this is really that bad. Like, it is what it is. What is at? Or what is the default? What is the return type for at? Oh, it outer ranges. Yeah, I'd like to avoid calling contains before find. Yeah, somehow an empty list is making its way into here. I don't really know why, but it just exists for some reason. So I think this is reasonable enough. Anyway. Let's just run test one more time. Okay, I didn't break anything. Let's commit some stuff. Let's at the front end. We do temp variables made by temp variables made by English elides me. What is happening? Front end. Fix weird empty list. How long have you been coding in C++ for? Honestly, so I've technically learned C++ like my second quarter of schooling here. So if that's the benchmark we're going from, I've been writing C++ for like 3 years. If the question is like how long I like have been like writing actual like real substantive C++, I think that starts from like just this past summer, honestly. I think the total amount of time I've written like real C++ that isn't like truly like hand-holdy tutorial code is probably like, I don't know, like 7 substantive months total out of all of that time. So yeah. Why C++ over Rust? I will say I do like Rust more. The only reason I'm using C++ is because a lot of the compiler world uses C++ for the large projects, and I just need more practice with C++. There's not much else of a reason, to be honest. I think C++ is also just currently a more quote-unquote employable language, just because there's a lot of legacy code bases that require C++ at least. Okay. So we fixed that thing. What the hell do we do now? Yeah, guess we can look at the tests again. This doesn't really change anything I was thinking about, I guess. I need to figure out allocate hoisting in some way. So if we can just like pre-initialize all of these allocates instead of like dumping them all over here. How many allocates are here? There's only 41 this time. How about that? That might be a lot of allocates, but, you know. Sure. Maybe I could actually just make a temporary second value for that. Even, There's definitely ways I can make this more efficient, but, largest stack frame, or actually, I might just take the rest of this stream just to like make the front end allocate code gen a little bit more efficient. Cause I'm scared that this will break something somewhere. LVM is written in it, yeah, exactly. I think the types of roles I'm targeting mostly are just like LLVM sort of roles. Let's see how Godbolt handles this code actually, this test. Let's do that. Let's nuke some of this stuff. Let's do O0. Oh, right. Right, yeah, I forgot. We, okay. So all the allocate. So how does it handle this giant slush pile at the bottom? Interesting, there's only 2 allocates here. It looks like it just makes a temp reg, almost. Or it just uses a temp. Actually, wait. Huh. Well, I guess that makes a lot of sense. You did debate? Yeah, I did policy, yeah. I also did like collegiate debate for a couple years, but it turns out collegiate debate's really difficult, so I have since dropped that in pursuit of this neat little thing called employment. Yeah. Okay, I don't think there's a way we can clean up this code gen, to be honest. Or not even code gen, just like this stuff here. I think we should definitely figure out hoisting these allocates to the entry block if at all possible. Or at least if there's a way we could do this like more efficiently, maybe. The Polysian High School is gonna do it at Dartmouth? I see, yeah. That makes sense. Yeah, Dartmouth's quite a monster school right now, I think. They're doing quite well, but UMich might just run away with it all, I fear. Okay, let's figure out hoisting. How the hell do we hoist when we make temporary variables? This should all go at the top, I think. It should go in AST to HIR. I think that is right, unless yeah, all variable declarations we can just throw at the top, right? If we look here, yeah, we can just put all of these at the top, and I think that solves our problems. Lots of consistent work to reach, yeah. That's how a lot of things go, I feel like. What type is result again? Is this a list? It's a vector. Damn it. Okay, we're gonna make a list so I can insert front. Yeah, let's do that real quick. This goes in here. I know nothing about compilers with C++. How much percent is this finished? In terms of like something that generates code, I think it's a solid like 70% maybe. I think there's like one more hard algorithm after tree tiling, which is just register allocation, and then I can kind of just like vomit out code. Everything else from there is optimizer work. Both like in the back end and in the middle end. So like the part that generates the code and then the part that I guess optimizes, does most of the heavy lifting for optimizing. Yeah, I haven't given this spiel in a while. I think it's time. This is like the whole compiler architecture 101, or like the crash course of it. So let's say we're trying to make a compiler that is like very modular. So we take like, for instance, the C language, and then we want to compile it down to like x86-64 assembly. So that's one quick compiler here. You can just like do everything just like as like one big program. But the problem with this, I guess like the reason why we need to like split up the compiler into different stages is we want it to be as scalable as possible. So let's say we want to support more languages like C++, or we want to add like Rust to it as well. And then like let's say we want to like write Swift code as well for some reason. And then we also want to target a bunch of different backends. So we also want to just target like 32-bit x86 for some reason. And then we also want to target like some sort of ARM. And the problem here is doing this naively, you have 4 languages and 3 backend targets. So you need to write a total of 4 times 3 compilers, because each language needs 3 compilers, 1 per backend. So if we draw the lines, that works out to 3 times 4. So that's m times n compilers. So obviously this is a little bit untenable. So the people that have been doing a bunch of compiler research, they came up with a new solution, which is to make this black box middle end sort of. And this, I guess, very frequently is just like LLVM's IR. IR stands for intermediate representation. This is just like a generic memory representation of, I guess, assembly or a program, depending on how you look at it. And the reason this is useful is then you can just write 4 different compiler front ends down to LLVM IR, and then you can write 3 separate backends. So instead of writing m times n compilers, you can write m plus n mini compilers. So that's like the basis of a lot of compiler design. And this is also really helpful because you can also reuse optimizations for the IR. So this is like opt, I guess. So then this splits the compiler into like 3 main phases, I guess. You can kind of divide it like this. You have the front end here, and the goal of the front end is to literally just take the code, turn it into LLVM IR, or just whatever IR you're using. There's the middle end, which is, I guess, strictly just the optimizer. The goal here is to make the code just faster and more efficient in whatever metric. And then there's a backend, which handles turning this IR into assembly language. So that's like the big spiel. Yeah, so I'm gonna pull a new graphic here now. I guess I don't really need to make a new graphic for this. So I guess like in the front end, we do like, it's basically just like simplifying the language down to more constituent parts. So like, for instance, things like turning like control flow structures into just like jumps and branches, or like converting variable scopes into just like global variables that are flat at one level. That's like most of what my front end does. There's like some other like small syntactic sugar things it does. It also handles things like those like compound operators. It's like 1 plus 2 plus 3 plus 4. You have to handle that in some order. And you also have to handle like operator precedence. So that's all handled in the front end. The middle one does a bunch of optimizations. So like if you have 1 plus 1, you don't need to compute that every time. You can just replace that with 2. That's an optimization called constant folding. That's like kind of like I guess like the simplest example. There's a lot of other crazy stuff that happens. You like unroll loops. You do a bunch of stuff with memory. Overall, you just make a more efficient program. And then the backend is kind of where I'm currently stuck. And this has a lot of different stuff. You need to like generate actual assembly because the IR doesn't map one-to-one onto any of these, so you need to like do a bunch of tricks to get around it. I mentioned this a little bit at the start of the stream. English is hard. The other big thing it needs to do is it needs to do register allocation. So when we're writing code, we have like pretty much infinite variables to work with. But I guess at the metal, we only have a certain number of like literal like registers that we can work with that are like fast. And we want to take advantage of those as much as possible. So we want to fit as many variables into those as we can. And everything else we'll just have to like leave on memory and just eat the cost. Yeah, that's kind of like the big crash course on why compilers are designed the way they are. And you can see this design sort of roughly illustrated in my code as well. Language frontends can have their own IRs. Yeah, that's you can kind of like throw IRs at any point in here. IR just stands for intermediate representation. So like Swift and Rust both have their own. Clang has an IR. Yep. If you've heard of MLIR, that's a big place that's useful. Here I have like I have a second front end IR that handles just like desugaring, I guess. And then like the backend, I'll have like the backend. I was thinking of having like a separate IR before CodeGen proper, just as like virtual registers versus like literal registers. But I decided against that. But yeah, that's like the crash course. You should use Arch Linux. I do actually. My laptop is running Arch. I take it to class. I work on it everywhere other than my room. I'm only using Windows on this machine because, well, I play Valorant, and there's no way around Windows for Valorant, unfortunately, I fear. So, I do just have to deal with that. It is what it is. Let's check fantasy again. Jalen Hurts is not doing well. This is good. Two birds with one stone, because now I'm closer to winning again, and my Eagles fan friend is going to be malding, which is going to be really funny to see. Yeah, let me know if you have any other questions about like just like broad strokes compiler design. I think that's where I can like do the most explaining. I think like the nitty-gritty is where my understanding is a little bit weaker. What was I gonna clean up again? Oh, hoisting, right, okay. Is it really that bad to take this and turn it into a list? I feel like I should turn it into a list regardless. But what's the cost for merging vectors? That's linear, right? Gotta go, thanks for streaming. Yeah, thanks for showing up, Samir. Hopefully I pronounced your name correctly, apologies. Thanks for showing up and have a good one. Okay, I need to figure out hoisting. That's what I want to do. I'm going to make this a list because we're nuking the hell out of the cache anyway. I don't care about the vector. Let's make this list. Or is it really that bad, actually? Is it that bad if I just copy everything over? Let's ask ChatGPT. Is it faster to keep two vectors and join them, or use a list? And append front sometimes. Okay, well, okay. I guess we're keeping a second vector. Okay, so we can do result. And then we can do allocays. We should hoist the allocays. If you're not familiar with the term hoisting, it's like we're literally just moving the instructions to the top of the program. JavaScript is very famous for doing this, and that caused a lot of problems. But here we're literally just moving all of the variable declarations to the top, so I don't think that's really that big of a deal. I'm sure it's fine. At least in this instance, because it's just the declaration, which is distinct, I guess. Okay, this all goes in here still. Okay, or wait, huh? Yeah, declarations should all go at the top. So this is the first one. This should be allocays, or I guess like declarations. Now let's name it that. Yeah, so this is a declaration. This should be, do that. Do that. This is in call, okay. Do that. Okay. So every time we make one, we should push it to declarations. That's good. Okay, and then what else can we do now? We need to modify getResult real quick. So we want to clear result, and we want to clear declarations. Oh wait, this might cause a problem because of the label. Right? Will this cause a problem? I guess if we're merging them, it shouldn't cause a problem. They should all go after the entry label, I think. Okay. I think that's fair. Do you want to do it like this, or? Or actually... If the entry label is going to be the first label anyway, what we could do is we could just push the entry label onto... yeah, we could push this onto declarations. Yeah, we could do that. We can push it like that, and then... and then we need to like push just some like generic label onto... yeah, make label or unless the label is already made for us, which would solve all of our problems. Or I guess actually that doesn't really matter, right? Where's like our general visit? Yeah, okay. We could just start without a label. I don't think that'd cause an issue, to be honest. Yeah, so we do that. So make the params. Revisit the body. Yeah, that's actually fine. This is perfectly fine. And then we clean it up. Okay. Yeah, okay. Let's do that actually. And then if we look at the example output, call chain, the HR here, the entry, we don't really care about labels other than just like entry existing. So I think this should be good. Yeah, so then we need to combine the vectors. I guess splice would be nice though. Joining would require moves because they store unique headers. Interesting. Okay. That's nice. Okay. I've been told reserve can be dangerous sometimes, so I'm not gonna reserve actually. Let's just do it the safe way. Let's just paste that in. Okay, so we want... Alright, so we want declarations. Oh boy, I can't write. Declarations, we want to insert result and... Or no. Declarations and... We want to move from result begin, result end. Yeah, so we can do that, and we should move declarations. Yeah, so then we clear result after we move it. Okay. Hopefully this works. That'd be very cool if it worked. After this, that also makes a lot of our code gen a little bit easier because all of our allocates are hoisted then, which will be very helpful. Okay. Oh wait, maybe I shouldn't do it at this stage. I should do it at the next stage. Wait. Yeah, I should definitely do it between these two. Wait. Wait. How would it look in here at least? Okay, let's look at the headers so I'm not lost again. It's been a while since I've looked through this file. Wow. Yeah, the declarations we can kind of just throw at the top actually. Yeah. Yeah, we should definitely do it like this. Because current instructions is already a list. So we don't need to like deal with like conversion stuff here. Let's actually stash this in case this causes problems down the line. I don't want to completely condemn myself to rewriting it. So let's just stash that. This is already a mess, but it is what it is. So this should be, yeah, this should be allocates. We have a list of allocates there. Yeah, okay. So this should be allocates. Yeah, so that's the only instance. What else do we do? Terminator, we make a basic block. I think we should just like, at the end, connect basic blocks. We should... Or wait. This is an HR to MR, okay. Yeah, let's make a create entry block helper function here, actually. That might be the least awful way to do this. So create basic block, void, create entry block. This takes nothing. Why did I need entry block again? What the fuck was I doing here? Oh, I know why. Yeah, I need that. Alright, this should return our MIR basic block putter. How compilers in theory should be some of the buggiest software in existence? Yeah, it for sure should be. It's very messy. It's actually just like such a software engineering marvel that they even work, to be honest. That's my opinion, at least. Okay, so this goes above connect basic blocks. Yeah, this type is correct. Yeah, okay. So we want... So we want basic blocks, or we want to... Where is create basic? Oh, it's right here. Nice. Where do we call this? And the entry block is just the front block, right? Yeah, it's the front block. So we want to kind of want to just copy this stuff into here. Yeah, so we can do this. This should be push front, actually. Right? What is basic blocks? It's a list. Yeah, so push front exists. So we can do that. This should be, instead of current instructions, this should be allocates. We need to make a terminator real quick. What the fuck is happening here? Oh, we take a terminator, I see. So where's the straight line? Yeah, so we can do that. This one we don't really need to link into anything, I think. How do we link basic blocks at least? Handling only user input and there's infinite variations? Yeah, it's very adversarial, at least the way you have to think about it, I feel like. It is quite easy to find bugs, but, or very easy to accidentally leave bugs, but it is what it is. It's rewarding in its own way. I can't really complain. Okay. What am I doing? Gotta go now. Thanks for streaming. I'll try catching Relics. Well, yeah. Have a good one. Thanks for stopping by today, Relics. Okay, so let's throw that there. That's Terminator. That. Let's just return that. Yeah, that seems reasonable. This should actually just take what we had in here before. Just as long as this linking thing just iterates through the map, not through the basic blocks. Okay, we might have to we might just have to null pointer this then. We'll need to link it up as well. So call, or not call, we care about branch. Yeah, so we want that. So we want that, and then we want, what's the label? What? What the hell? Oh. Oh, that's annoying. So what type is this? This is a identifier, okay. Huh. Well, that doesn't work how we want it to, huh? Yeah, okay. Yeah, we don't want to we don't want to cause any mess here actually. So, how do we link these then? This is such a messy way of doing this though. This is terrible. I hate this. Oh, we should do this after linking, actually. This is fine. Maybe we could just like... Yeah, this is fine. We just have to run this after linking them. So we want basic blocks front get. Yeah, let's put this after connect basic blocks so I don't mess it up. Hypothetically. Where's the part? Yeah, so we connect before this point. So we just want create entry block. Yeah, let's do that. And hopefully this works. Hopefully this hoists. Let's just run. If we wait for it to build real quick. Generate. Oh no. That's not supposed to happen. Oh no. All right, let's run debug bin. Let's just run a test on this. Let's Valgrind. Create entry block. Default delete. What the hell are we deleting? Oh, right. Huh. Why is that empty? Oh, are we? Yeah, we're getting the basic blocks. Lol. Whoops. Okay, let's take this. Let's throw that there. Let's try that again. What? The hell? Alright, more Valgrind. More debugging. Everyone's favorite activity. Remove edge. The hell? We could just not make a new block, to be honest. We could just append to the front. That might be the play. I don't know. Maybe, maybe not. Let's just do O0 here. Or dump MIR. Yeah, there's the big allocate pile. So that does what we want it to. How does this have a branch? No, it doesn't. So we should probably just like not make a new block here. So we can just like let's just paste this onto here. Yeah, we can get rid of that. And then yeah, we can just tack this onto the top block, to be honest. I think that's fine. Even if it like makes a little bit of a mess. I imagine when we care it'll get cleaned up. So we want basic blocks front. We want to get instructions. List insert list front. Oh, splice. Okay. That's nice. So we can splice, and then this takes entry block instruction, or we can do this. Let's delete that. And then we do this. We want to splice that, begin. Yeah, and then let's give it ret, or no, just allocates. And hopefully this works. This should hoist as well, but in a less ugly way. Okay, yeah, so that's just tacked onto the front now. So now if we run the test runner, there we go. Okay, it all passes. So this seems a little bit better than the other solution I was thinking about, which was at the other, I guess like further up in the compiler chain. So I think that could be prone to errors, so I think this is the best way to do it. Hoist allocates in HIR to MIR. Okay. The reason this is important is because when we're doing, I guess like, when we're doing instruction selection, this is also where we need to worry about calling convention. And one of the important things there is just figuring out how much stack space we need. And my hope is that this will at least give us a more concrete number on how much stack space we need. This will also be very useful when we like make when we make like arrays. So that will be very nice if we could do that. We can look at some of the tests real quick actually from this. Let's go to test. Actually, let's just look at mir.mir. Yeah, so yeah, some of these will be a little bit chunky, but that's kind of inevitable, I think. Yeah, I think the code is also just generally more readable, which will be very helpful when figuring out what's happening, because all the allocates are in one place now. And this is also per function, so we don't have issues with other things. I think that'll also like get rid of just a bunch of random like allocate slush in the middle of programs. Like what does this generate now? Yeah, so like all the allocates are in one place. Yeah. Yeah, and then we can like cogem that in a pretty way, I guess. There's a lot of crazy tree merging that's happening here. There's a lot of loads. Okay, well, I hope this is all correct. This seems fine at a glance. What the fuck is happening here? Should be easier to cogen? Yeah, hopefully it is. That's my hope at least. What are we loading? Okay, something is awry here. Huh. I'm not sure that output's correct, but maybe we give it a simpler test. So presumably this is with the add. I don't think these should be eating up allocates anymore though. I think the allocates should just get in assembly mode now. or node. What did it look like before? There are a bunch of allocates just like scattered throughout. I need to figure out what's happening here though. Because something is definitely not right here, I think. Or, yeah, we should not have an allocate in here. I don't know. I'll figure that out next time. We might have to defer. We might have to defer tree tiling for a little bit. Anyway, yeah, that's all pushed. I think I'm gonna call the stream here today. I really need to do game dev homework. Thank you all so much for showing up to today's stream, especially if you're new here. The growth across the past 3 months has been incredible, and I'm very grateful to all of you for that. If you haven't already, make sure you like the stream and sub to the channel. It helps out with the algorithm and gets my content out to more people. While you're down there, you should join the Discord. That's the best place to talk to me and the rest of the community, and also get notified when I go live. Everyone is really chill. It's just a really nice place to hang out. Of course, aside from that, in the description is also my GitHub and my LinkedIn. Feel free to add me on those if you want to stay up to date with what I'm doing. Yeah, that's about it. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.